In this video, we're going to look at distance along small circles. Distance along small circles is also known as distance along parallel of latitudes. Why is it stated as parallel of latitudes? It's parallel because every small circle is parallel to the equator. You can see this from like C, A, B, C. It's a small circle. They are all parallel to the equator, except the equator. Every other small circles are parallel to the equator. So that's why by name. In this video, we're going to look at distance along small circles, which is also known as distance along parallel of latitudes. So this is any distance along the latitudes except the equator. Here, distance between any 2 points on latitudes along A, B, C, D, E is derived as shown below. So, assuming X to be a point on the Earth's surface with latitudes alpha, of course, XY is a small circle with radius r. So this is a small circle which is parallel to the equator. Okay, so the radius of this small circle is alpha, is r rather, small letter r. And then, of course, XY is a small circle with radius r. The resulting triangle OPX, has cos alpha equal to r over the big R. So where r is the radius of the Earth, and then the small r is the radius of the small circle. First, you know that from OX is this r is the radius of the Earth, because any distance along the equator is a great circle. So that's to say that both the great circle and the small circle, they are related. So thus, to calculate the distance of any 2 points on this parallel, to calculate the distance of any 2 points on the parallel of latitudes, we apply the formula. Distance is equal to theta over 260 degrees times 2 pi r, but r is equal to r cos alpha from this relation from here. So cos alpha is equal to r over r. So r is equal to cos alpha. Okay, r cos alpha. So that's to say that the radius of the small circle is related to the radius of the Earth by this function. So in place of r distance formula, which is the length of the minor arc subtended at the center by this angle, which is the angular difference, we're going to have so this r is related to the radius of the Earth by r cos alpha. So in place of r, we put r cos alpha. So where theta is the angular distance of the points on the longitude, so east or west, alpha is the angle between the given parallel of latitude and the equator. That is, latitude measurements is to north or south. So in a nutshell, remember that the formula for the only difference between this formula and that of the great circle is that for great circle or distances along the great circle is that distance is equal to theta between any distance between any 2 points on the great circle is equal to theta over 260 degrees times 2 pi r, where r is the radius of the Earth. But distance along the parallel of latitudes or small circles is distance, we'll call it small circle, is equal to theta over 360 degrees. Distance over 360 degrees times 2 pi r cos alpha. So this function here is what differentiates distance on small circles from distances on great circles. So, and this alpha is gotten from the angle that is subtended, the angle between, and this angle is the angle here, that's cos alpha, and it has to do it. So okay, so where theta is the angular distance, this theta is the angular distance of the points on the longitude, so east or west. Alpha is the angle between the given parallel of latitude and the equator. That is, latitude measurement is to north or south. So let's take some examples. Number one, calculate the radius of latitude 75 degrees north. So to get the radius of latitude 75 degrees north, it means like from our diagram, if you are to get our diagram, what it implies is if this the parallel of latitude is the parallel of latitude, the radius of it is the radius of the small circle r. So that's what it implies. This is a small circle and this is the radius from the center. So center of this small circle is SSO. So this is the radius you are asked to calculate. And the formula is r is equal to r cos alpha. So the radius of latitude 75 degrees north will give us 6,400 times. But if you are not given r, the formula for r arbitrarily, the arrow has the value 6,400 or 6,270 kilometers. So that's what we're going to use. Times cos 75 degrees north. So 6,400 times cos 75 that's 1,656.44 kilometers. Okay, so I'm going to round it up to two significant figures, 1,700 kilometers to two significant figures. Number two, find the distance measured along the parallel of latitude between two places with the same longitude. So you have this. Alright, so this is the equator. Okay, now the question says you should find the distance measured along the parallel of latitude between two places with the same latitude, 18 degrees south. Let's say this is latitude 18 degrees south and with longitude 96 degrees east. 96 degrees east. Alright, so this is longitude 96 degrees east, and then the other one is longitude 57 degrees east. Longitude 57 degrees east. 57 degrees east. So this is the first point, and this is that point, and both points are lying on this parallel of latitude. So the center of this latitude, line of latitude, is this. So the radius will be from here to this point. So draw it down. So join these 2 points. Alright. So let's say this is point E. The first point is 96 degrees east. So let's say this is E and here is B. Yeah. Let's move on. So the question says should find the distance. So distance is measured along parallel of latitude, and distance is measured along small circles, because every parallel of latitude is a small circle except the equator. And you have parallel of latitude when the 2 points are lying on the same line of latitude. Anytime 2 points are lying on the same line of latitude, you will have a small circle. Conversely, anytime 2 points are lying on the same longitude, you're going to have a great circle. And anytime points are measured from the equator, it's a great circle. But if those 2 conditions are not fulfilled, every other measurement is measured along the parallel of latitude, and that is a small circle. So first thing we're going to do is to get our angular difference. So our angular difference, Now what you observe is that you have something like this. So we have point A and then we have point B. So for this circle, So for this circle now, from here, from the this is okay. So this is the radius. So from this pole to this point is for B is equal to 57 degrees, and here to 57 degrees, and also from here to here is also 96 degrees. So what is from here to here? From A to B. To get that angular difference, we're going to have since both sides lie on this the southern hemisphere of the globe, we're going to subtract the smaller longitude from the larger longitude. So serious 96 degrees minus 57 degrees. 96 minus 57 is equal to 39 degrees. And the latitude, in this case alpha, is equal to the latitude on which the 2 points are lying on. So latitude 18 degrees south. So we're going to say distance between distance AB is equal to, so that is arc, minor arc AB is equal to, since the distance is measured along the parallel of latitude, which means the 2 points are lying on the same line of latitude, and say theta over 360 degrees times 2 pi r cos alpha. This will give us 39 degrees over 360 degrees times 2 times 22 over 7 times 6,400 times cos 18 degrees south plus 18 degrees. So this will give 39 times 2 times 44, 39 times 2 times 22 times 22 times 6,400 times cos 18 times 10,44,883.08 divided by 360 degrees. 360 times 7 gives us 2,526. So 4144.79 kilometers, and this will give us 4,100 kilometers to 2 significant figures. So that's the distance between A and B along the parallel of latitude. Number 3 says, okay, so here we have, so number 3 says X and Y are two places on the Earth's surface such that X is latitude 60 degrees north, latitude 60 degrees north, and this is it. So this is the parallel of latitude 60 degrees north, and the radius is this. So it's also related to the equator. Alright, so this is latitude 60 degrees north, 60 degrees north. So here's also 60 degrees by alternate angles, and this is the radius of the small circle. So let's say the center of the small circle is C, the small center of the great circle, which the equator is O. Alright, and here is R. Okay, and this is the right angle triangle. Now the question says X and Y are two places on the Earth's surface such that X is latitude 60 degrees north. So this is latitude 60 degrees north, and we have then the other point is longitude 30 degrees east. Longitude 30 degrees east. So 30 degrees east, this is longitude 30 degrees east, and that's for X. Then Y, latitude 60 degrees north, longitude 85 degrees east, longitude 85 degrees east. So this line is longitude 85 degrees east. So we have 2 points. We have here point X, longitude X is 30 degrees north, and here point Y, So from here, this like this, and this like this. So we have a line like this, and then we have here like this. I have a sector, so E, B. Alright, so from here to here, from the from this pole to B, so B, okay, to X, so X, and then here's Y. So X is equal to 30 degrees, and from here to Y is 85 degrees. So from Y to X, the angle has to give us angular difference. So angular difference, since both X and Y are on the eastern side, or are on the same side of the hemisphere, that will give us an angular difference is theta is equal to 85 degrees minus 30 degrees. So 85 minus 30, 55 degrees. So that's, oh, okay, that's, it is find the sectorial angle measured along the parallel of latitude. So this is sectorial angle which we have gotten here. So here's 55 degrees B. So this is A sectorial angle. So B says if the radius of the Earth is 6,400 kilometers, find the radius of the parallel of latitude. Remember that the radius of the Earth, R, is related to the radius of the Earth by R is equal to R cos alpha. If you consider triangle COY here, so we're going to have triangle CO, let's say here is D, which is a right angle triangle. So the radius of the Earth is equal to radius of the parallel of latitude is equal to radius of the Earth, which is 6,400 times cos alpha. Alpha is the latitude on which both X and Y are lying on, which is 60 degrees. That will give us 6,400 times cos 60 degrees. That's 3,200 kilometers. Number one, A, latitude 60, point A is at latitude 60 degrees north. Point A, latitude 60 degrees north. Latitude 60 degrees north. Longitude 45 degrees east. Longitude 45 degrees east. So this is point A. Point B is on latitude 60 degrees north, same latitude, but longitude 15 degrees east. Okay, so that's okay. There's B, longitude 15 degrees east. So let's get point. So point A, which is longitude 45 degrees east. So point A. So these 2 points are lying on the same latitude. So this is the radius of this latitude. From here, connecting to this point, so we have something like this. Sector. So A, B. This is 15 degrees east, 15 degrees, and from here to here it gives 45 degrees. So what's this angle? Okay, so calculate correlatively significant figures, the distance between A and B along the parallel of latitude. So let's get our angular difference. Angular difference is angular difference theta is equal to 45 degrees minus 15 degrees. 45 minus 15, 30 degrees. So theta is 30 degrees. and both of them are lying on latitude 60 degrees north. So the alpha is 60 degrees north. So the distance between A and B along distance AB along the parallel of latitude is equal to 30 degrees over 3, 60 degrees times 2. We're told to take pi to be 22 over 7, and then radius of the earth 6,400 kilometers, 6,400 times cos 60 degrees times cos 60 degrees, and this will give us, so here 0 cancels 0, 2 here 1, 2 here 12, 2 here 1, 2 here 6, 2 here 11, 2 here 3, and okay, so we have 11 times 6,400 times cos 60, 3520 equal to 3520. And now here the denominator is 3 and 7, so that's 21. So 3520 200 divided by 21, that is 1676.19. The question says the answer should be correct to 3 significant figures. So this is the first, this is the second, this is the third. So 1680 kilometers to 3 significant figures. So that's one. Then number two. An aeroplane flies at 650 kilometers per hour along the parallel of latitude. 650 kilometers per hour is speed. Speed is 650 kilometers. 650 kilometers per hour along the parallel of latitude from a point X. So X, a point X. Alright, so from point X, okay, the altitude from a point X 15 degrees south. The latitude 15 degrees south, 10 degrees west, 10 degrees west. So this is longitude 10 degrees west. So point X. So here's point X. And then, so Y 15 degrees south, parallel of latitude, 15 degrees south, 48 degrees west. 48, yes, longitude 48 degrees west, point Y on the same line of latitude. So now this is a small circle. This is a small circle. So the radius would be from here to here, since it's a small circle. So connect here and connect to this point. So our angle, sectorial angle, is of this form. So you have this and you have this. So this is Y and X. So from here to here is 48, 10 degrees, here is 10 degrees, and from here to here is 48 degrees. So what's here from Y to X? So the angular distance theta is equal to they are both lying on the same western hemisphere of they are both on the same side of the globe, which is the west. So we're going to subtract 48 degrees minus 10 degrees. 48 minus 10, 38 degrees. 38 degrees. And so the next thing is to look for the distance between X and Y. So the distance XY is equal to theta over 360 degrees times 2 pi r cos alpha, since the distance is measured along the parallel of latitude. So, and this will give us for theta 38 degrees over 360 degrees times. We're told to use pi 3.142 times 3.142 and 6 out of 400 kilo. That's the radius of the Earth times cos. The parallel of latitude is 15 degrees. That's cos 15 degrees. And that will give us 2 here, 1, 2 here, 180 degrees. So 38 times 3.142 times 6,400 times cos 15. That's 7738097.15 divided by 180 divided by 180 4100.54 kilometers. Okay, so that's the distance. And the question says we should calculate the time spent by the aeroplane to fly from X to Y to the nearest 1 hour. So since we got the distance and we're given speed, so now let's calculate the time it would take the plane to fly from X to Y to the nearest 1 hour. So speed is equal to distance over time. Distance over time. So we're to look for time. Therefore, time, make time the subject of the formula. Time is distance. Time is distance, speed over distance over speed. Distance over speed. So distance is 4,100.54 divided by speed 650 kilometers. That is 4100.54 divided by 650. That's 6.3331 hour. So to the nearest 1 hour is equal to 6 hours. To the nearest 1 hour. So the time taken by the plane to fly from X to Y is equal to 6 hours to the nearest 1 hour. Alright. What is the angle between 2 points P and Q whose longitudes are 102 degrees east? So between P and Q, so P is on 102 degrees east. 102 degrees east. So this is longitude 102 degrees east and 30 degrees P. Okay. Line on latitude 30 degrees south. So both points are lying on 30 degrees south. Latitude 30 degrees south. So this is point P, 102 degrees east and latitude 30 degrees south. And then Q is lying on 38 degrees west. 38 degrees west. Longitude 38 degrees west. And then this Q lying on latitude 30 degrees south. Alright, so the question is, what is the angle between the 2 points? So since both of them are lying on the parallel of latitude, the center of this small circle is this R. Okay, so join these points together and these points together. So though this part is not necessary. Okay. So we want to look at this angle. What we have now is we have so this point. So we have here the sector of the angle here. So we have here. So P, angle P, and then Q. So here we have P and Q. So between longitude 102 degrees, 102 degrees, and Q is longitude 38 degrees, 38 degrees. What's the angle? The angular difference. Angular difference theta is equal to, since P and Q are not on the same side of the globe, P is on the east, Q is on the west, so the angular difference will be that of addition. 102 degrees plus 38 degrees. 102 plus 38, that's 140 degrees. So this angle is 140 degrees. So that's for 2. That's for number 1. That's the angle between the two. Number 2 says calculate the parallel of latitude 60 degrees north. Use R. Parallel of latitude. Parallel of latitude. Of latitude 60 degrees north. That's R is equal to, okay, that is R is equal to R cos alpha, and R here is 6,400. 6,400 times cos alpha is the latitude 60 degrees. So 6,400 times cos 60, 3,200. 3,200 kilometers. Number 3. 2 villages are on. Number 3 here. Number 3. The 2 villages are on 15 degrees south. So it's latitude 15 degrees south, 107 degrees east. So this longitude 107 degrees east, and 15 degrees south, 17 degrees east. Longitude 17 degrees east. So let's say this is X and this is Y, and the center of this small circle is this. So that's what we have. So now we have this. So X and Y. So here's 17 degrees, 107 degrees. What's XY? So the question says, respectively, what is their distance apart along the line of latitude? So first of all, let's get angular difference. Angular difference theta is equal to, they're on the same side of the globe, so we subtract 7 degrees minus 17 degrees. 90 degrees. So here's 90 degrees. 90 degrees. And since the distances are measured along, since the distance is measured along the line of latitude, so distance xy is equal to theta over 260 degrees times 2 pi r cos alpha. Now, so, and this will give us theta is 90 degrees over 260 degrees. We're not giving value for pi and r. We're told to express our answers in terms of pi and r, times 2 times pi times r times cos 15 degrees latitude, cos 15 degrees, and this will give us 90 or 1. 90 here is 4, 2 here, 1, 2 here, 2. We're not going to get the value of cos 15. Yes. So what we have left is pi r cos 15 degrees over 2. So that's the final answer. Pi r cos 15 degrees over 2. The final answer. So in the diagram below, r is the radius of the great circle, and so this is the radius of the great circle, which is equator, and r, which is lowercase, this r is the radius of the small circle, x, y. If r is equal to 6,400 kilometers, and that's the radius of the great circle, and also the radius of the Earth, and angle W angle OX is 50 degrees, which is this part here, this angle. Find the perimeter and the area of the small circle. Give your answers to two significant figures. Take pi equal to 3.142. So here, in triangle OXC, in triangle OXC, O angle X, O angle X is equal to 50 degrees. How? Ultimate angles. So if triangle O angle X is ultimate angles, then from triangle OXC, you can see adjacent over hypotenuse, which is cos 50 degrees equal to adjacent, which is r over hypotenuse. So r is equal to r cos 50 degrees. So that will give us, remember the question says we should look for, first of all, the perimeter of the small circle. So this r is equal to r cos 50 degrees. So the perimeter of figure 1, perimeter of the small circle is equal to, and perimeter is also known as circumference of the circle, and the formula is 2 pi r, where but r is equal to r cos 50 degrees. So perimeter is equal to 2 pi r cos 50 degrees, and this will give us, I told you to use pi 3.142 and r is equal to 6,400 kilometers. 2 times 3.142 times 6,400 times cos 50 degrees. Two times 3.142 times 6,400 times cos 50, 2581.37 kilometers. But the answer should be correct to two significant figures. So this is the first significant figure, this is the second, and the next one is more than 5, so we round up, make it 0, add 1 to this, 1, 2, 6, 1, 2, 3, 1, 2, 3 kilometers. That's 26,000 kilometers to two significant figures. Then one figure 2 says we should calculate the area of a small circle. Area of area of small circle is equal to pi r squared, but r is equal to r cos 50 degrees. So the area is equal to pi 3.142 times r cos 6,400 cos 50 degrees squared plus plus 50 degrees squared. And will give us 3.142 times 6,400 cos 50 4113 4113.84 squared. 3.142 times 413.84 squared. 169 236 79.55 times 3.142 531.1742 4301 1.28 kilometers. So and this is equal to kilometers. This is equal to two significant figures. 1, 2. The next one is not up to 5, so we round down. 1, 2, 3, 4, 5, 6. So 5, 2, 0, 0, 0, 0, 0 kilometers. Two significant figures. That's 53 million kilometers. Kilometers squared because it's area. Alright. Find the longitude difference between A 60 degrees north, 40 degrees west, and B 60 degrees north, 70 degrees east. B. Find the distance measured along the parallel of latitude between E and B. So I'm not going to draw the diagram, just want to proceed to E. Since the 2 points are on latitude 60 degrees north and they are not on the same side of the globe, this is the point A is on the west, point B is on the east. So angular difference theta is equal to 40 degrees plus 70 degrees. That's equal to 110 degrees. So B says find the distance measured along the parallel of latitude. Distance AB along the parallel of latitude is 360 degrees times 2 pi r cos alpha. So the distance is equal to pi is 22/7 and r is 6,400 kilometers. 110 degrees over 360 degrees times 2 times 22.7 times 6,400 times cos parallel of latitude 60 degrees plus 60 degrees 110 times 6,400 times cos 60 154.8800 360 times 7 gives us 2520 divided by 2520 6166146.03 kilometers. So I'm going to correct the answer to 2 kilometers. So two significant figures. I'll give us 6,100 kilometers to two significant figures. That's number 2. The two towns on the northern hemisphere are on longitude 50 degrees west and 75 degrees west. If they are 1,250 kilometers apart, find the parallel of latitude. North, south, west, east. So two towns on the northern hemisphere are on longitude 50 degrees west. Longitude 50 degrees. Longitude 50 degrees west. And the other, okay, let's show that both are on latitude on the northern hemisphere. So we are looking for, okay, we don't know this value. So let's say the first town is town E. Then the next one is on longitude 75 degrees west. Longitude 75 degrees west. So that's the longitude. So this is town E, and this is town B. This parallel line of latitude has its own center. So the center is the radius. Okay, so let's mix these 2 points. Connect. Alright, so this parallel of latitude is also related to the equator. Okay, so this angle, let's call this angle alpha radius of the earth. So now what we are going to look for, the question says we should look for the parallel of latitude as the angle. So we're going to look for alpha. All right, so okay, first thing first, let's proceed. Let's get, so what we have here is this shape. So E B is E B. E is 50 degrees and B is 75 degrees, both on the northern hemisphere. So we're going to subtract angular difference. Angular difference theta is equal to 75 degrees minus 50 degrees, 25. That's 25 degrees. So now to get to the distance, we do that. Okay, distance AB is equal to theta over 260 degrees times 2 pi r cos alpha. So dot distance is equal to 1,250 kilometers, which is given to us here. So 1,250 is equal to angular difference, which is 25 degrees times pi is 3.142 and r is 6,400. 2 times 3.142 and 6,400 times cos alpha, and here it's over 260 degrees. So 1,250 is equal to 25 times 2 times 3.142 and 6,400. That's equal to 1005440 cos alpha over 360 degrees. So we cross multiply. So we have 1,250 times 360 is equal to 1005440 cos alpha. The cos alpha is equal to 1,250 times 360, 486, 486,000 divided by 1005440 cos alpha is equal to 0.4834. Alpha is arc cos 0.4834, and alpha is shit cos 0.4834. So alpha is 61.09 degrees, and alpha is 61 degrees north. So the nearest degree. So the latitude of the latitude is 61 degrees north. That's the answer. The positions of two places on the Earth's surface are P, latitude 45 degrees south, longitude 20 degrees east, and Q, latitude 45 degrees south, longitude 100 degrees east. So first it will get latitude 45 degrees south. Yeah. South and longitude. So for P, longitude 20 degrees east, this longitude 20 degrees east, and so this point P, Q is longitude 100 degrees east. Write P here. It's P, so this is Q, point Q. So now this small circle is the other part. So the radius, okay, so connect here, connect here. So we have, so the center of this circle is C. C, the sector, so P and Q. So from the center, rotation from this pole, so here will give us 20 degrees. So CP 20 degrees. Then from C to Q, that will give us 100 degrees. So the angular difference is calculate the distance between them along the parallel of latitude. So this is the angular difference, theta, that is theta is equal to, now they are the same hemisphere, as they are, both points are on the east, so that will give us 100 degrees. We're going to subtract 100 degrees from 20 degrees. From 20 degrees, and that will give us 80 degrees. So distance PQ is equal to, theta equal to 60 degrees times 2 IR cos alpha. So here theta PQ is equal to 80 degrees or 260 degrees times 2. The theta is 3.142. 3.142 times 6,400 times cos 45 degrees. Eighty times 2 times 3.142 times 6,400 times cos 45, 22750 51.015 divided by 2, 60 degrees. 6319 0.59 kilometers. So okay, so the two significant figures, so 63000 kilometers to two significant figures. That's A. So B says, now also note that since this is the radius, if you connect it to the equator, so the parallel of latitude here is the angle. So the parallel of latitude here is 45 degrees rather, and so the which is alternate. So the center, the equator has O as R. So and here is R. That's O. Then call O. Next call here. Let's say D, which is the parallel of latitude, 45 degrees. So OD is R, which is the radius of the Earth, and also the radius of the great circle. So if here's 45 degrees by alternate angles, here's also 45 degrees. 45 degrees. Okay. So now the question says we should find calculate the vertical distance between the center of the Earth and latitude 45 degrees south. Between the center of the Earth and latitude 45 degrees south. So we're going to have also from triangle OC, from triangle OCD, which is this. So this is D, and here is 45 degrees, and this is the radius of the great circle, which is also the radius of the Earth. Center of O, and this is the center of the great circle, and this is the center of the small circle, OCD, and we have to look for OC. So now that will give us opposite over hypotenuse. So OC over R is equal to sine 45 degrees. Sine 45 degrees. So OC is equal to R sine 45 degrees. Now R is equal to 6,400 times sine 45 degrees. So that will give us 6,400 times sine 45, 5.4824 kilometers. This is vertical distance from the vertical distance between the center of the Earth and latitude 45 degrees south. Approximately 4500 kilometers to two significant figures. C. So C says how far is Q from the equator? So how far is Q from the equator? So if we measure, want to know QO. So if you measure from the equator, remember the equator is only 45 degrees. So the distance from Q to the equator will give us distance of Q from the equator. The equator is equal to theta, and that's great circle, because any distance measured from the great circle is any distance measured from the equator is a great circle. So theta over 2 is 60 degrees times 2 pi r to 45 degrees. So that 360 degrees times 2 times 3.142 and 6,400. 9 here 5, 9 here 14, 5 here 1, 5 here 8, 2 here 1, 2 here 4. So that will give us 3.142 times 6,400. 20108.8 divided by 4. So divided by 4. 5027 kilometers. That is 5,000 kilometers to two significant figures. K, latitude 60 degrees north, longitude 50 degrees west. So K is latitude 60 degrees north, latitude 60 degrees north, and W longitude 50 degrees west. 50 degrees west. So this point K, and it's a point on the Earth's surface. L is another point due east of K. So if L is due east of K, it means that both K and L are lying on the same line of latitude. So due east of K, let's say this point L, I will draw a line of longitude. So this is point L. Point L. Then we told that and the third point N is due south of K. So due south of K means that it's lying on the same line of longitude. So we need a line of latitude across. Okay. Let's draw. So due south of K. So this point N. Now the question says the distance KL is 3,520 kilometers and Kn is 1,951 kilometers. Calculate A, the longitude of L. So that's this line, longitude of L. So since this one is the KL, the 2 points are lying on the same parallel line of latitude. So it's a small circle. So let's get, and this was the radius. It's this. So and it's connecting these 2 points together. So let's say this is C. So we have here this and C KL KL and we have this line. So we're looking for the KL is longitude 50 degrees. So let's call this X. We don't know, we are really want to know the longitude of X. So since let's solve with A. Well, let's begin with A. Since KL is due east of K, it follows that K and L are on the same parallel line of latitude. Which is 60 degrees north. So the angular difference theta is equal to 50 degrees plus X, because point K and L are on different parts of the globe. L is on the east and K is on the west, so we add the angles together. So since they are lying on the same line of parallel line of latitude, distance KL, distance between K and L is equal to theta, or actually 60 degrees times 2 pi r cos alpha. So but that KL, distance KL, but distance KL is equal to 3,520 kilometers. So 3520 is equal to 50 degrees plus x over 360 degrees times 2 times pi is 22 over 7. 22 over 7 times 6,400 times cos 60 degrees. 2 here, 1, 2 here, 180 degrees, 2 here, 90 degrees, 2 here, 11. So 11 times 6,400 times cos 60, 35,200, 3520 is equal to 50 plus x. Okay, 50 plus x, 35,200 over 90 times 7, 630. So cross multiplying. So 3520 times 630 is equal to 50 plus x, 35200. So 50 plus x, 50 plus x equals to 3520 times 630, 2217600 divided by 35200. So 50 plus x equals to 2 divided by 35200, that's 63. So x is equal to 63 minus 50, and x is equal to 13 degrees. And therefore, the longitude of L is 13 degrees east. So B says the latitude of N. So since N is due south of K, it implies that they are it implies that N is on it implies that N and Q are on the same longitude, So, and that implies that is they are 2 points on a great circle, So from the equator, join these 2 points together. So let the latitude of N be y degrees south. So we're going to say angular difference theta is equal to angular difference theta is equal to what we have is so K N and K is longitude 50 degrees west, longitude 50 degrees west, latitude 60 degrees north, 60 degrees. Since you're on the same line of longitude, the latitude will be different. So K is on latitude 60 degrees north and Y, and N is on latitude Y degrees. So the angular difference is 60 degrees plus Y. So distance K and along the great circle, because they're on the same line of longitude, is equal to theta over 360 degrees times 2 pi r. So but distance the distance K and is equal to 10,000. The distance was given to us as 10,951 kilometers. So 10,951 is equal to theta is 60 degrees plus y time over 360 degrees times 2 times 22 over 7 times 6,400. So 2 here 1, 2 here 180 degrees, 2 here 11, 2 here 90 degrees. So 10,951 is equal to 60 degrees plus y. That's y, and 90 here, 90 degrees. And then 11 times 6,400, 70400. 90 times 7, 630. So here's the one cross multiplying, cross multiplying. We have 10,951 times 630 equal to 60 degrees plus y. 60 degrees plus y. 70400. So 60 degrees plus y is equal to 10951 times 630. 6899130 divided by 70400. I'll come over here. So 60 degrees plus y is equal to divided by 70400. 97.99. 97.999. This is 60 degrees plus y is equal to 98 degrees. So y is equal to 98 degrees minus 60 degrees, and y is equal to 98 minus 38 degrees. Therefore the latitude of N is 38 degrees south. 38 degrees south.